Hello, in this video we're going to do an application of differentiation which is called the marginal analysis. Now just to recall, C of x was the cost function, R of x, which is x times small p of x, was the revenue function, where the small p of x was the price function, not the profit but price function, and capital P of x will be the profit function, which will be the revenue function minus the cost function. Just to recall this much, we've done this in previous videos. Now, if the question is to find the marginal cost, we'll denote it by MC, marginal cost. All you have to do is differentiate the cost function. Similarly, if the question is to find the marginal revenue, all you have to do is differentiate the revenue function. And if the question is to find the marginal profit, you will have to differentiate the profit function. So remember this much, that if the question is to find the marginal of any function, all you have to do is differentiate it. So let's see an example. Okay, I give you small p of x to be, say, 10 minus 0 minus 0.002x. Say this is your price function, where x is the number of units at your company. Whatever you're making or whatever you're selling is the number of units x. So let's see question 1. If I tell you find the domain of the price function, now if you're selling anything in your company, the price should always be bigger than or equal to 0. So 10, so whatever the price function is, should be bigger than or equal to 0 always. And also remember that x is always bigger than or equal to 0. And then all you have to do is solve for x. So move this on the other side. 10 becomes bigger than 0.002x. So divide by 0.002. So x becomes less than or equal to 5,000. So what does that mean? That x lies between 0 and 5,000. So it's bigger than or equal to 0 here and less than or equal to 5,000. So this is your domain. So it means your domain is from, if you try to draw this, from 0 to 5,000. So if the question is to graph anything, I will see that later, but if the question is to graph anything, it should only be between 0 to 5,000, because that's your domain for the problem. Okay, next question. If I say find the revenue function now, so it is just x times p of x. We'll use the same p of x as before. So it's x times 10 minus 0.002x. So that becomes 10x minus 0.02x squared. This is your revenue function. Okay, now if the question is find the domain of the revenue function. So remember the domain of the revenue function will be the same as the domain of the price function. So you don't have to do anything. All you have to do is just put the same thing here. 0 to 5,000 is the domain. Okay, so I give you the cost function as well. Say 8,000 plus 2x, something like this. Okay, now the question is find the marginal cost function. So all you have to do is differentiate this. Differentiation of a constant is 0. The differentiation of x is 1. 2 times 1 is 2. The marginal cost is 2. Now the main thing here is to explain the meaning of this. So remember, if you're doing application, you will have to explain the meaning of your answer. So the meaning of 2 here is every additional product you make, it will cost you $2 or £2 more, whatever the unit is. Let's say it's dollars. So whatever additional unit you make, it'll cost you $2 more. So for example, if you're making 10 units, say it's costing you $12. Then if you decide to make the 11th unit, it will increase by approximately $2. So it should become $14. So to make the 11th product, it should increase by $2 more than the previous one. Okay, similarly, if I tell you to find the marginal revenue function, all you have to do is differentiate this. So that is 10 minus 0.004x. Right? Because you use the power rule here, you multiply this with 2 and you get the answer. Let me just check something quickly. Okay, now if the question is find the marginal revenue at, say, x equals 10 units, just like we did here, right? This was a constant, so it's constantly increasing by 2. But this is a function of x, so what you'll have to do is, in place of x, you'll have to plug in 10. So it'll be 10 minus 0.004 times 10. 10 is a small number. Let's do 1,000 here. So if you multiply this with 1,000, you get 10 minus 4, which is $6. Now what is the meaning of the $6? Is that if you make a 1,001th unit, so if you increase the production by 1 unit, your revenue will increase by $6. And the same thing can be applied to the profit function. So if the question was find the marginal profit function, first you find the profit function by doing Rx minus Cx, and then differentiate it. And if it's telling you to do it at x equals, say, 1,000, you plug in 1,000 into x, and whatever answer you get, that much profit will either increase or decrease when you make the next unit. So very important to explain this number here. What does it mean? This is $6, not 16. Okay. So once again, the meaning of the $6 here is, if you make the 1,001st unit, your revenue is expected to increase by $6. And this is the application of differentiation, marginal analysis. If the question is telling you to graph anything, you should only do it from 0 to 5,000, because that is the domain for this problem. I hope that made sense. Any questions, you can type it below.